Okay, close your eyes for just a second. I want you to imagine a completely dark world, a planet that is never, ever going to see a sunrise. No dawn, no twilight, absolutely no warmth from a familiar, distant sun. You know, we're so used to planets that are just bathed in starlight, but what happens out in the absolute extremes of the cosmos? Well, you can go ahead and open your eyes now, because today's explainer is taking us to the very edge of imagination, to a place where planets are literally forged in the shadows of the most destructive forces in the entire universe.
Over the last decade or so, there's been this quiet revolution happening in theoretical astrophysics. We're moving way beyond those thousands of exoplanets we've found orbiting dead stars or red dwarfs. Now, we're looking at the possibility of a completely new class of object, something so strange and so entirely dark that astronomers actually had to coin a brand new and honestly kind of playful name for them. So what the heck is a planet? It's exactly what it sounds like, right? A black hole planet. For centuries, our whole definition of a planet has been tied to light. First, it was these wanderers in the night sky reflecting sunlight, then rocky or gaseous spheres orbiting stars. But to really understand the planet, we basically have to throw that whole star-dependent idea out the window. We are talking about worlds that form around and orbit supermassive black holes, those absolute monsters sitting at the centers of almost every large galaxy, with masses millions or even billions of times greater than our own sun.
Section 1. Planets without a sun.
To really wrap our heads around what this means, we have to look at the pitch-black reality of these extreme environments. Think about a normal planet, like our Earth. It's totally defined by its star. It gives us our day and night cycles, it gives us warmth. A Melanoplanet, on the other hand, doesn't orbit a star. And actually, it's not a rogue planet either, just aimlessly drifting through empty space. No, it is permanently tethered to a supermassive black hole. It exists in absolute total darkness, but, and here's the wild part, it's bathed in this invisible, incredibly lethal glow of X-rays and gamma rays. So how could a planet possibly form in such a hostile, bizarre place? Section 2. The accretion disk nursery.
Well, the answer isn't actually in the black hole itself, but in all that chaotic, swirling material surrounding it. We call this the active galactic nucleus, or AGN. When a supermassive black hole is actively feeding, all this gas, dust, and even whole stars fall toward it, flattening out into a glowing, spinning accretion disk. Now, the inner regions of this disk, they are quite literally some of the most violent places in the universe. We're talking temperatures easily hitting millions of degrees. You've got magnetic fields twisting into colossal plasma fountains, and particle jets shooting out at almost the speed of light. On the surface, this sounds like the ultimate destroyer of worlds, right? Definitely not a nursery for them.
But here's where it gets fascinating. If you travel far enough away from the black hole, say maybe 1,000 to 1,000,000 times the distance between the Earth and our sun, the outer reaches of that exact same accretion disk actually become surprisingly calm. Out here, the temperature absolutely plummets to just tens of degrees above absolute zero. In this freezing, ultra-quiet zone, dust grains made of things like silicon, carbon, and iron can actually survive. And there is a staggering amount of this material out there. Thousands of times the mass of our entire solar system is just waiting there, in the dark. For a really long time, this was just seen as a fun, theoretical quirk. But then, back in 2019, we had a major breakthrough. Astrophysicists Kiichi Wada, Yusuke Tsukamoto, and Ichiro Kokubu ran these incredibly complex supercomputer simulations. They wanted to answer one simple question. Could those surviving dust grains actually clump together and form planets inside that disk? And the answer they found wasn't just a yes, it was a resounding yes, but with a pretty massive twist in how the whole process actually works. What's totally incredible here is the sheer difference in speed. See, in a normal protoplanetary disk around a star, dust grains bump into each other, they stick together, and they very, very slowly collapse under their own gravity to form planets. But around a black hole, the immense gas pressure of the accretion disk basically supercharges that whole process. It violently forces the dust to concentrate into dense layers. And once those clumps reach a few hundred meters across, they act like giant cosmic vacuum cleaners, just rapidly sweeping up all the material around them. So the main takeaway here is that planets form incredibly fast. While a normal planet might take many millions of years to take shape, planets pop into existence in just a few 100,000 years. I mean, that is literally an eye blink in cosmic time. And they're huge. These simulations didn't spit out gas giants like Jupiter. Instead, they forged these massive super-Earths and mini-Neptunes, weighing anywhere from 1 to 10 Earth masses. These are rocky, icy worlds, probably wrapped up in thick hydrogen envelopes. But don't let that fool you. Because they're embedded in a disk glowing with extreme radiation, their surfaces would be totally sterile, highly irradiated wastelands for sure. Section 3. The Blanet Life Cycle. All right, so we've got these massive, dark worlds forming super rapidly. But what happens to them next? Well, the life of a planet is just as brutal as its birth. It's born in darkness, it lives fast, and it dies in silence. The exact same gas that accelerated its birth immediately turns against it, creating this massive drag that forces the planet to slowly, inevitably spiral inward. Over a few million years, the planet migrates closer and closer to the black hole. Immense tidal forces start to stretch and distort it. And for a lot of these worlds, the journey just ends by plunging right across the event horizon, simply adding their mass to the singularity. But plunging into the abyss isn't the only way this ends. Sometimes, gravitational chaos in the disk, like maybe close encounters with other forming planets, can act like a giant cosmic slingshot. A planet can be ejected entirely from the galactic center, becoming a rogue planet just wandering the void. But keep in mind, these aren't your average rogue planets. A rogue planet carries a very specific, unique chemical pedigree. It's heavily enriched with exotic heavy elements that were forged exclusively in the ultraviolet environment of an active galactic nucleus.
And then there's arguably the most eerie survival scenario of them all. What if the black hole simply stops feeding? The active disk completely dissipates, the gas drag stops, and the planet is just left behind. A completely dark world orbiting a dark heart. It will circle that dormant black hole for billions of years in total silence. Its only source of illumination, the incredibly faint red-shifted glow of the cosmic microwave background.
Section 4. How to find them.
So this brings us to the most frustrating yet totally exhilarating part of today's explainer. How do we actually find something that emits zero light and orbits a literal shadow? To really put this challenge into perspective, just think about this number, 26,000 light years. That's the distance to Sagittarius A star, the supermassive black hole at the center of our very own Milky Way galaxy. Even if a planet exists right there, it is so small, so dark, and so impossibly far away that on our best existing cameras, its angular size is way smaller than a single pixel. We absolutely cannot just point a telescope and snap a picture of a planet.
But you know, astronomers are kind of brilliant at finding the invisible. They look for indirect signatures. Think about it like this. Just as a planet clears a path in a stellar disk, a massive planet might carve noticeable gaps in the millimeter wave emissions of an accretion disk. That's actually something the ALMA telescope array is actively looking for right now. Or, if a planet transits across the hot inner region of the disk, it could cause this tiny periodic flickering in the X-ray light, a dip that future massive surveys like the Rubin Observatory's LSST might just be able to catch. And of course, there's always gravitational microlensing, where the planet's mass literally bends the light of a background star. Though, to be fair, picking that out in the incredibly crowded galactic center is a monumental task. Section 5. Why planets matter.
Now you might be wondering, if they are this ridiculously hard to find, why do we even care? Why does all this matter? Well, it matters because it fundamentally challenges everything we thought we knew about the universe. First off, it forces us to ask a really basic question. What actually is a planet? Does it absolutely have to orbit a star? But even more mind-blowing is how this shifts our entire view on habitability. Look, nobody thinks the sterile surface of a planet could ever harbor life. But what about its moons? A massive planet sitting out in the cooler outer regions of that disk could easily have moons with liquid water oceans. They wouldn't be heated by a sun, obviously, but by immense tidal forces from the black hole's gravity and the background heat of the disk itself. The chemistry there would be utterly, completely alien, and there would be no daytime at all. But it opens a door to the staggering possibility that life just might find the strangest paths imaginable.
And this naturally brings us to a spectacular, albeit speculative, look into our own cosmic future. Fast forward a few billion years from now, and our Milky Way galaxy is going to collide and completely merge with the Andromeda galaxy. When that happens, an enormous flood of fresh gas is going to pour right into the galactic center. Sagittarius A star, our currently very quiet supermassive black hole, is going to violently wake up. A massive new accretion disk will form, and out in the freezing outer edges of that new disk, dust will stick together and grow all over again. Brand new planets will literally be born right here in our own galaxy. As the quote perfectly captures, they will never know a star, they will never feel the warmth of a sun, but they will exist, silent, dark, and perfect, circling an invisible heart long after the last normal stars in the universe have finally faded away.
Which leaves us with this final, truly profound thought. Imagine billions of years from now, deep in that dark age. Will a future civilization, perhaps huddled around a dying dwarf star, look toward the center of our newly merged galaxy, not searching for the light of stars, but searching for the tiny, rhythmic dimming that reveals the shadows of planets? It's a hauntingly beautiful possibility, and it just goes to show how incredibly creative, extreme, and awe-inspiring our universe truly is.